This tutorial is about how to use BabySteps in the Wellbore Simulator. In BabySteps, what we do is we make one run and then we use the results of the run as the starting point or initialization for the next run, and then in the next run we will modify the data slightly in order to get to the next step of the problem. So in a number of steps we would carry on sequentially, making a run, getting the results of that run, and using that as the initialization for the next run. Now especially for steam circulation type problems, we would normally want to start off with a very hot reservoir, because that is the easiest case to run when there's a steam path all the way from the injection tubing back along the annulus, back along the short tubing. Now sometimes as we cool down the reservoir, we're going to decrease the steam quality and eventually condense the steam into a liquid water. And when the reservoir is cold, say at initial startup, that's exactly what happens, is that the steam coming down the long tubing condenses the liquid and then comes back up the short tubing riser as a liquid column, and it requires additional pressure to lift up the column. To demonstrate those things, I'm going to take up a steam circulation problem, open up a steam circulation problem, and steam circulation problem, this one here. This is a steam circulation problem, and I'm going to show you the pipe data. The pipe data is a long string and then a short string. So the steam is injected in the long string and then it returns back up to the short string. And in this particular system we have the reservoir data at about 100 degrees centigrade. So we're starting off as a fairly heated reservoir already, and we want to cool it down in baby steps so that we can run the initialization with a cold reservoir. So in the case of a 100 degrees C reservoir, and we're going to inject about 100 meter cubes of steam with an injection pressure of 2500 and an off-take pressure of 400. So we have a 2100 kPa difference in this circulation path. So when we run it, we would be able to get a answer. We open the run data file, start the runs, and when the run finishes, we look at the results, and the results of the run, selecting all the tubing strings, the casing, the long and short tubing, looking at pressure, looking at the water, cold water equivalent of steam, and looking at steam quality flowing into the segment. I can save the report selection for future use and show the report. And in this report, we show that we're injecting 1856, enough to push 100 meter cubes of steam back to a takeoff pressure of 400 kPa at the short tubing string. And we have initially a steam quality of 85% steam quality, coming down to the toe of the valve, returning on the casing liner, back up to the heel of the valve, and up the short tubing, up to the wellhead of the short tubing at that off-take pressure. So it's about 29% steam quality, and the steam, this is steam path all the way from the injection long tubing, back up the annulus, back up the short tubing. So now if we step down, we want to use baby steps. So I'm going to look at the same file again, and Now I'm going to open up the file I just ran, which is a 100° C case, and I want to take the pipe data, and I want to baby steps. So in baby steps, we are going to use the same file, the file we just ran, which is the same 3 pipes, so we can use it for all the pipes. And if we browse that to get the file that we just ran, which is this case here, 100° C case, and that is the 100° C case, 100 meter cubes. We're going to use the same file for same results file that was what we ran just now as the input data for each of these pipes. And therefore, when we do that, we're going to ignore all initialization that's been placed in this data file. It will be overwritten by these initial conditions. Okay, so for all pipes browse, and then we can select the file that we want to start from, and this is how we do baby steps. So this one way is to read back the previous file and start that. Now for reservoir data, we're going to step down from a hot reservoir to a cooler reservoir, trying to get back to our initial conditions, and then we're going to maintain the same injection profile. So that 2500 is our injection pressure and 400 is our offset pressure. If we save that file and then run it, we're going to save it, say, at 50° C, baby step 1, and save it. I had done this before, as you can see. And then we can then make the run data file, and start the runs. Sorry. Pick up the file, 50° C, and we can start the runs. After several minutes of running, the thing has completed, and it is looking at the messages. We can see that look at messages. The program has taken 300 cycles, and it's got up to a situation where it has reached a previous minimum of 0.263, and after 300 cycles it did not bring it down as good as this one, and so it repeated the run with the last minimum gradient, which is this one, and stopped. So this is the best possible answer that we could get under these circumstances. So if you open up the results and get last safe report selection, we can see that the model has done a fairly reasonable job at giving us an answer. So with the steam quality coming down the tubing was 85%, coming down to 60%, and then going over into the annulus, and then 16% going back up to about 14%, 15% flushing as it dropped pressure to the top. And that 1785, 400 kPa was what we used for the injection pressure difference. So this has cooled down, but it's still a steam path all the way from the injectors, long tubing, down to the toe and back along the annulus and back up the short tubing. It's still a steam path, so our pressure difference is not that dramatic yet. So we're going to now take the same case and do another baby step. And in this baby step, we'll cool down the reservoir down to the 15° C, say, initial condition, and then we will see how we can run it. Let's close this file. And then we're going to open up the data file, which is the same one here. We can use this option, open up the data file. And the data file, we previously browsed and we baby step using the 100° C case. Now we're going to use the results of the last round, 50° C case. And we're going to browse for all pipes because we're going to use the same conditions for all the pipes in the last run. And browse, and we're going to choose the 50° C case. And we want now to change the reservoir temperature to 15° C. And we're baby stepping from a previous answer of 50° C to a new condition on the rest of 15° C, and we'll keep the same production injection profile. pressures. Now if you look at our trajectory, our depth of the well is actually 426 meters. So assuming a water head of say 10 meters, we will have a liquid head of 4,000 kPa to overcome. So if you look at the production data, we will never be able to overcome the 4,000 kPa. So when we make this run, we will never converge, because it's not possible to overcome the written head of liquid of height 430 meters, and we don't have the kind of pressure difference to do so. So when we try to make that run, I'll open the results of that run, the 15 degrees C run. If I open up the results of that run, what we see is that it's not a converged solution. It's not a converged solution. We do not get the 100 meter cubes of steam coming back up. Our steam quality is 0. In the short tubing, it means that it's condensed. It has condensed about almost to the toe of the long pipe, and coming back is all liquid coming back along the annulus and up the short tubing. So we would not know this until after we run the case that we don't have enough pressure head to do so. And one thing we can do quite frequently is to lower the trajectory factor as a way to see whether that's really one of the questions that we have to answer. And if you look at the data file, this is the same data file. If you look at that data file, and if you look at trajectory, is 1. So the pipe data would show the pipe schematic going up this way. One way to make the program easy to run is to bend the riser section almost flat. So if you use the trajectory factor of say 0.1, and then close this to redraw it and go back to pipe data and display pipe schematic, we have flattened the reservoir to 0.1. So in this case here, we don't require as much a pressure head because our depth is no longer 400 meters deep. We have a flattened reservoir. And in this case, we will then run easily in using the colder reservoir temperature. So if we browse again using the BabyStep 50 degrees BabyStep and reservoir data of 15 degrees C, and if we save the data file and run it, we run it. The run is stopped after a few minutes, and then now we look at the results of the run. And we can show it for the 3 pipes. We can show that for that pipe schematic, flattened reservoir, we have a pressure profile, and we look at the water rate, and we can look at the steam quality. You can see the steam quality that is going hot. The steam quality is going down, decreasing as it goes through the long tubing, and as it returns along the annulus, it becomes condenses to water and returns essentially as water. And for the model, is showing us that for the cold reservoir, the data says okay, except that our pressure difference needs to be higher in order to be able to return that head of water. So what we need to do is we need to go in and open the data file, and we need to really, instead of changing the elevation, it's just an example of how to do baby steps. We can also change back to level factor 1 and show that as a straight pipe, a vertical pipe. But in our production injection data, we can change it up to say 6,000 kPa, and then we save this data file and run it again, and then we can see what the necessary pressure is to return the liquid head of water. So let me just double click and restart the run again. So after a few minutes, the run is completed, and we can look at the results of this run. Open the results of this case and get last save report selection. Show it, and again the steam quality is decreasing down the long tubing, and it condenses to all liquid. About this 7 goes down to the toe of the well, returns as liquid head all the way up. And you can see our pressure is 4,000 kPa in order to return the head of water. If we display a pipe schematic, you can see that is the drop in pressure in the water head, in the water filled pipe. Next parameter is water, and the steam quality, so it condenses to liquid about here, and then it goes all the way as liquid up to the top. So in this tutorial, we've shown how to use BabySteps, and in BabySteps, essentially what you would do is you would open, after the run is completed, you want to make a change to the data, for example, changing reservoir data or changing trajectory in different leveling factors, say 0.1, 0.2, 0.3, 0.4, 0.5, and so on, in sequence. For different changes the data, you go to pipe data, and you will browse all pipes and select the previous run that you want to use from. Okay, and that is how we do the baby step for Wellbore Simulator. Thank you very much.